time of practical revision, I would like to make a short video regarding my practical to make my knowledge, to recall my knowledge and to move forward in my coming days. Okay, if I want to recall my this thing, so for that I am preparing this video. So I like to share this thing. Where is my? Okay, I like to share this screen. I have already told before about this AND gate and NAND gate. Okay, if in AND gate, okay, if both input is high, then only output will be high. Okay, uh, otherwise the output will be low. But if there is a small bubble in AND gate, okay, because here we can convert this figure up to over here. If there is a small bubble, then this AND gate will be converted to NAND gate. This NAND gate is zero sensitive gate. Okay, in my point of view, I can call it as a zero sensitive gate. So whatever be the input, if any one input is zero, output will be high. If any one input is one, output we cannot predict. Okay, see here, if any one zero, output will be high. Okay, if any one, if this is one and this is not given, we cannot predict this zero, because if here is zero, the output can be high. Okay, so this is the thing. This is not gate. Okay, this is not gate. Not gate can be replaced by this AND gate by combining these two or these three. We have a 3-input NAND gate in 7410 IC. We have a 2-input NAND gate in 7400 IC, but don't forget to give ground to 7 and 14 BCC. Okay, and this we have already known about the 1-bit memory. After that, we'll see 1-bit comparator. What do you mean by comparator? Comparator means comparing the value, whether the value is more or less. Okay, so this is the comparison of A is greater than B. Okay, suppose let's see A is 0, B is 0. Suppose A and B are equal. Okay, in this case, so what will be the output? If A and B are equal, 0 comes here, and this 0 will be converted to 1. Okay, this 0 comes here, 1 comes here, and 0 1, then output will be 1, because this is NAND gate. If any one input is 0, output will be high. Okay, if both input are high, then only output will be 0. Okay, so in this case, 1 is our output will be 0, because there is NOT gate. Okay, so in this case, we are saying there is no any output. That means A is not greater than B. So this gives only a high output when A is greater than B. So now same thing is repeated for all other values. Now I will take here A greater than B. Then only I can see here the output is 1. Okay. Okay. I'll directly go to A is greater than B. Other we can directly predict by this simple thing. Okay. In this experiment, in this thing. Okay. Here A is greater than B, A1, B0. So in this case, what happens? 1 comes here, which is 0 coming, 0, 1, totally converted to 1, because they not get. Okay, 1 1 1 1, then what will be the output? 0. Output 0, then here y1 will be 1, because again not get 1. That means it is saying that the output is correct. The input was correct. Input was correct. That means A was greater than B. Otherwise, it was wrong. So see here, A is greater than B. So I don't want to go to all other term. Okay, one thing I want to try here. Out of the 4 0 0 1 0 1 1 0 1. Okay, I want to go here 1. Let us give A and B both equal 1 1. That means 1 coming here, here 0. Same thing happen, 1 0 then 1. Here will be 0. Okay, same thing. This is the circuit diagram of A greater than B. Okay, not other, A greater than B only. In this circuit diagram, we can have this truth table. Okay, this one truth table we can have y1. Okay, y1 truth table is fulfilled. That means if both A and B are 0, output is 0. If both A and B are if A is 0, B is 1, that means A is more than B. Oh, sorry, A is less than B. So this is wrong. So there is 0 output. Here A is greater than B, so there is 1 output. So A and B are equal, but this is the checking of A is greater than B. So this is false for this term. So only this one is correct. That is A is greater than B. A is 1 and B is 0. Okay. Okay. This is correct for this. Now next one is next one is A is less than B. Simply get this, take this NOT gate to the upper one, A. Okay, your NOT gate, this NOT gate will be converted to, taken up to A. Okay, this NOT gate was in B. Now simply take it to A, you will get the answer. So let us see here. If A is 0, B is 1. Because A is less than B. If A is 0, B is 1. Then 0 is less than 1. It is true. True. Result will be true. Okay. So let us see whether the result will be true or not. This 0 coming here. This is 1. 1 coming here. 1. 1, 1. Then the output will be 0. Okay. 1, 1. Then output will be 0 in AND gate. So this 0 coming here. Then Y3 will be 1. So let us see here in truth table of this Y3. Okay. Because we'll not see this 2, we'll see only this 1. So in this case only we are getting 1. In the case of A and B, 0 and 1. That means B is greater than A. B is greater than A for this term. Okay. That means this is fulfilled. Now another circuit diagram is for A is equal to B. Okay. That means we are taking this Y2. Output as a Y2. So in this case, when A and B are equal, then only the output will be, here the output will be true. That means 1. Okay, high output will be. Okay. Now, I forgot to give A and B. This is A, this is B. Suppose, let us say here both are 0. 0, 0. That means A is greater, A is equal to B. In this case also we will get the output high. So if 0 is here, then here also 0. If any one term 0, from here also 0 coming, but any one 0, then the output will be high. Okay, and here is 0. And this 1 is divided into 2 NAND gate. So whatever it is divided, from here it is coming 0 straightly, and from here it is coming 1. So this 1 do not play a vital role. Here is 0, so here will be 1, because NAND gate is 0 sensitive. So you will get the 1. Here is 0, we'll get here 1. Okay, 1, 1. Then what will get here? 0, 0. And this is the NAND gate. Oh, NOT gate, sorry. I told you before that this NOT gate, if we don't get a transistor, don't get resistor and all, then we can simply take this 7400 IC, which is 2-input IC, 2-input NAND gate IC. So combine this and make a NOT gate. Okay, this is a NOT gate. I told you before. Okay, this and these are equal. So here is 0 coming, then the output is 1. That means we have a true output. A and B are equal. So in this other case, let's take A and B not equal. Okay, in that case, what happens? This one. And again, we'll take A and B equal 1, 1 later on. Okay. Okay. In this case, we have given 0, 0. So here, in case of 0, 0, Y2 is high. Y2 is high. Y2 is here. Okay. For this, the truth table is this one, Y2 AB. For upper one, Y3 AB. And for a little bit upper one, Y1 AB. Okay. So let's not make equal 1 and 0. Okay. From here, 1 coming, no prediction here. Okay. Here also 1, here also 1. So from here 0 coming, then from here 0, okay, here also 0. Then this NAND gate is 0 sensitive, this output will be 1, and this 1, 1, the output will be 0. Okay, here 0, output will be 1, and 0, 1, output is high, 1, then NOT gate gives output 0. See, A and B are not equal. False result, okay? Okay. I want to take one more example in this by taking A and B equal 1, 1, because before we have taken 0, 0. In 1, 1 also it needs to satisfy, no? Otherwise, our this circuit diagram is incorrect. So he will give a 1, will give a 1. Okay, 1, 1 coming, 1, 1 coming, then here 0, here 0. Okay, 1 coming here straightly. Okay, here 1, 1. From up 1, from down 1, so here 0, from up straightly 1, from here 0, then here 1, okay, here 0, here 1. If 1, 1, then the output is 0. If output here 0, here output is 1. So y2 is correct. Okay, we have got a true y2. So this is the simply explanation comparator. Okay, this three circuit diagram can compare easily. Okay, and compare easily. There is one little bit trick. Okay, then what happens if we combine these three in a same thing? Okay, I want to combine here one more thing. Okay, I want to combine these three things in a single experiment. If we combine this A and this A to a single A, okay, Utah one single A, and this B, okay, from here I'll jump to the other side and we'll take from here, okay, B, and from here, sorry, they need a jumping, okay, and from here we'll take B, okay, and from here if we take a single B, okay, single B if we take here, and whatever the data we give, suppose if we give a data 1 1, okay, and in output we'll give will place 1 1 LED, okay, 1 1 LED if we place in the output, okay, which can be run by that 5-volt battery, okay, or whatever volt you are taking as input, okay. So if we give both A and B 1 1, then which LED is going to light? Y2. Whatever the LED is here, that is going to light, because this give a false result. There is a very low output. LED cannot glow. So we can be sure that whatever the input is there, by looking only at the output, the input is equal, either 0 0 or 1 1. Okay, then this thing is going on. If we get this output, if LED glows here instead of here, okay, there is no any chance of glowing LED in three case. Okay, in three output at once, LED is never going to glow, because here the comparator is there. Okay, this comparator can be visualized in this term also. Okay, so here if we are sure that this A is greater than B, this LED is glowing, that means A is greater than B, that means A is high, B is low. Okay, the input is given by the other side. If you tell your friend to give input from the other room, and you will bring the LED in your room, and you can predict whatever the input is given by your friend. So this is a little bit trick to know. Okay. Okay. Thank you very much. I would like to stop over here. Okay. Thank you.